brings us one step closer to answering the ultimate question of our existence. Are we alone in the dark, expanding void of the cosmos? The James Webb telescope just peered into the atmosphere of a world 1,035 trillion kilometers or 705 trillion miles away and found a terrifying signal. Deep within the constellation of Leo, orbiting a faint red dwarf star, lies an exoplanet known as K2-18b. This distant world is completely unlike anything in our solar system. It is a massive planet shrouded in a thick, crushing atmosphere of hydrogen. For years, astronomers have theorized about what might exist beneath those impenetrable clouds. Now, the most powerful observatory ever built by humanity has captured the spectroscopic signature of a molecule that on Earth is only produced by living organisms. This monumental alien life discovery centers around a specific chemical compound known as Dimethyl sulfide. On our home planet, this exact molecule is generated almost exclusively by microscopic phytoplankton, thriving in the upper sunlit layers of the oceans. It is the chemical responsible for the distinct smell of the sea. There are no known natural, geological, or chemical processes on Earth that can produce dimethyl sulfide in significant quantities without the presence of biological life. When the James Webb telescope directed its near-infrared spectrograph toward K2-18b, it detected the faint but unmistakable absorption lines of this exact biological marker, sending shockwaves through the scientific community. To understand the sheer magnitude of this terrifying signal, we must first understand the extreme environment of K2-18b. This exoplanet is classified as a Hycean world, a theoretical class of planets characterized by vast global oceans of liquid water sitting beneath a massive, heavy hydrogen atmosphere. The planet is roughly 8.6 times the mass of Earth, and its radius is 2.6 times larger. The gravitational pull on the surface of this global ocean would be immense, creating water pressures that would instantly crush modern human submarines. Yet, despite these extreme conditions, the temperature profile suggests that liquid water can stably exist here. The red dwarf star that K2-18b orbits is much cooler and smaller than our own sun. However, the planet orbits at a distance of just 21 million kilometers or 13 million miles, completing a full year in a mere 33 Earth days. Because it sits so close to its host star, it is likely tidally locked. This means one side of the planet faces eternal blistering daylight, while the other side is plunged into permanent freezing darkness. The Terminator line, the twilight zone separating the day and night sides, could harbor the perfect thermal conditions for complex oceanic chemistry to thrive and continuously evolve. The James Webb telescope did not just simply find dimethyl sulfide. The atmospheric data also revealed an overwhelming abundance of carbon dioxide and methane, coupled with a severe lack of ammonia. In the field of astrobiology, this specific chemical imbalance is a massive indicator of a global water ocean. Ammonia is highly soluble in water, so its absence in the upper atmosphere suggests that a vast, deeply churning ocean is actively absorbing it from the sky. Meanwhile, the high concentrations of methane and carbon dioxide point to a complex carbon cycle, a fundamental prerequisite for the development of biological organisms as we currently understand them here today. Detecting these complex molecules across such an incomprehensible void requires a technique known as transmission spectroscopy. As K2-18b transits, or passes directly in front of its host star, a very tiny fraction of the starlight filters through the extreme edges of the planetary atmosphere. Different chemical compounds absorb very specific wavelengths of this starlight. By capturing the light that successfully makes it to our solar system, the James Webb telescope can read the missing light wavelengths like a cosmic barcode. The missing spectral bands of light perfectly match the absorption profiles of methane, carbon dioxide, and the highly controversial, terrifying signal of dimethyl sulfide chemical gas. The presence of dimethyl sulfide on a Hycean world forces us to completely and totally rethink the boundaries of habitability. For decades, the search for alien life discovery focused almost entirely on small Earth-like planets. We assumed that life required a solid surface tectonic activity, and a relatively thin atmosphere of nitrogen and oxygen. K2-18b shatters this terrestrial bias. It presents a terrifying, awe-inspiring reality where life might originate in the dark, crushing depths of a global ocean, shielded from stellar radiation. If biological entities are indeed producing dimethyl sulfide on K2-18b, they are likely microscopic, tiny single-celled organisms floating in the highest upper layers of the global ocean. In this extreme high-pressure environment, the water itself might behave very strangely, transitioning into exotic phases like supercritical fluids or high-density ice at the ocean floor. The sheer depth of this ocean could span many thousands of kilometers, creating a dark, abyssal world where sunlight never ever reaches the bottom. Any life forms existing here would have to rely on chemical gradients, or the faint, filtered infrared light from their red dwarf star to successfully survive. The James Webb Telescope operates at the absolute bleeding edge of human technology, pushing the limits of modern optical physics. The spectral lines for dimethyl sulfide overlap slightly with other non-biological molecules, making the data incredibly and highly difficult to isolate. NASA and the European Space Agency are already scheduling follow-up observations using the mid-infrared instrument, which will provide a much clearer, definitive look at the atmospheric composition. We are standing on the precipice of a massive paradigm-shifting revelation. Even if the dimethyl sulfide detection is proven to be a natural geological anomaly, the confirmation of a carbon-rich atmosphere over a liquid water ocean is a truly monumental scientific breakthrough. It proves that Hycean worlds are not just mathematical models, but real, physical places in our vast galaxy. There could be billions of these water worlds scattered across the entire Milky Way, vastly outnumbering lifeless, barren rocks like Earth. The James Webb Telescope has effectively opened a brand new frontier in the search for extraterrestrial life. The implications of a confirmed alien life discovery on K2-18b would fundamentally alter all human philosophy, religion, and science. It would prove that the genesis of life is not a miraculous, rare, isolated event unique to Earth, but a highly common cosmic imperative. If life can emerge in the dark, crushing, hydrogen-choked oceans of a sub-Neptune, it can likely emerge almost anywhere with liquid water and a constant, stable energy source. The terrifying signal from this distant world is a massive wake-up call. As we continue to carefully analyze the data from the James Webb Telescope, we must also consider the extremely violent nature of red dwarf stars. These stellar bodies are notorious for unleashing massive, highly energetic, destructive solar flares. Because K2-18b orbits so closely to its star, it is constantly bombarded by intense ultraviolet and X-ray radiation. On a rocky planet with a thin atmosphere, this radiation would quickly strip away the air and completely sterilize the surface. However, the massive hydrogen envelope of K2-18b acts as a thick, impenetrable shield. This massive protective hydrogen layer, while shielding the ocean from stellar flares, also creates a very powerful greenhouse effect. The atmospheric pressure at the surface of the ocean would be hundreds, perhaps many thousands of times greater than the pressure at sea level on Earth. The water might be extremely boiling hot, yet kept in a liquid state purely by the crushing, immense atmospheric weight pressing down upon it. Navigating the chemistry of such an extreme environment requires entirely new models of planetary science. From deep space, dimethyl sulfide isn't a greeting, it's an alarm. Possible life above boiling, hyper-pressurized, hydrogen-saturated oceans. If microbes endure there, life isn't fragile. It's waiting in places that should kill it. The next coming years will be critical as the James Webb Telescope continues its relentless scientific observation of K2-18b. Every photon of light captured from this distant Hycean world brings us one step closer to answering the ultimate question of our existence. Are we alone in the dark, expanding void of the cosmos? The terrifying signal of dimethyl sulfide is a faint whisper from the deep universe, hinting at a biological presence hidden beneath a crushing atmosphere of hydrogen. As we refine our instruments and gather more data, the definitive proof of an alien life discovery may finally be within our grasp. Thank you so much for watching. Please subscribe and help me get to that 1,000 subscriber milestone.